So continuing with 1.1, we're in the third video, 1.1c, and this is the real number line, top of page number 9. And there is a number line that you've seen ever since you were little. And one of the things that, if you remember, you've got 0 in the middle. All the numbers to the right are positive numbers. All the numbers to the left are negative numbers. So really all the negative numbers and positive numbers, the plus sign that's assumed in the positive numbers and the negative sign that are on the negative numbers, for the most part, all those positive and negatives mean is what direction from 0 is that number located. It's just a direction marker. Do I go left or do I go right? So if you are going right, you're going in positive direction. If you're going left, you're going in the negative direction. Now, one of the things that gets to be confusing is most of us know that when numbers get bigger and bigger and bigger, they get further and further away from 0. What happens to the left of the 0 is the numbers get bigger, but they get further and further and further away from 0. They get smaller and smaller and smaller. A negative 10 is a smaller number than a negative 1, whereas a 10 is bigger than a 1. So the further you get from 0 to the right, the bigger the number gets. The further from 0 you go to the left, the smaller the number gets. So just something to remember there. And brings us to the definition of a real number. A real number is any number that you can put on a number line. These are called coordinates, these numbers here. So any number that is a coordinate that you can label on a number line is a real number. So some numbers are real numbers, some are not real numbers. So real numbers that you cannot put on a number line, those would be non-real numbers. So I'm just going to kind of refer to the bottom of page 9, subsets of real numbers, meaning what numbers are there that are subsets, meaning let's say that we're just talking about whole numbers. Whole numbers is the set of numbers 0, 1, 2, 3, 4, 5, all the way into infinity in a positive direction. Negative numbers are not whole numbers. So real numbers include negative numbers, but whole numbers is a subset. And so it's a smaller set within real numbers that does not include the negatives. So there's some there. And top of page number 10 gives you a bunch of other things like irrational numbers and integers. So I'll let you go ahead and read that rather than me explain what you probably already know. Which brings us to the top of page 11 when we're talking about prime numbers and factoring. So prime numbers are numbers that nothing can be divided into it except itself and 1. So if we were to look at 17, there's nothing that you can divide, or nothing 17 can be divided by. Okay, so if we have 17 and you try to divide 2 by it, you can't. 3, 4, 5. There's no number that you can divide evenly into 17 except 1 and 17. 17 divided by 1 is 17. You can't do anything else with it. So therefore it's a prime number. So a list of prime numbers would be like 3, 5, 7, 11, 13, 17, 19, 23. Notice there are no even numbers there because every even number can be divided by itself, 1 and 2. So every even number is, there's no prime even numbers, but not all odd numbers are prime. 21, 7, and 3 both go into that. So don't just assume that because it's an odd number, it is prime. So one of the things that we're going to be doing is we are going to be looking for prime factors. So let me give you a little bit of a definition of a factor. Basically, a factor is if we've got the number 6 and the number 12. If we have a number that will divide evenly into another number, that number is said to be a factor of this number. So 6 is a factor of 12. 2 is a factor of 12. 3, 4. Okay, so anything that divides evenly into 12 is considered a factor. All right, so let's look. I had mentioned earlier we're going to talk about prime factors. So if we take all the factors of 12, 2, 3, 4, 6, okay? If we take the factors of 12, because 2 times 6 is 12, 3 times 4 is 12. These are factors, but they're not necessarily prime factors. 4 is not a prime factor. 6 is not a prime factor. And I'd mentioned earlier that even numbers are not prime numbers. 2 is a prime number because it's so small, nothing goes into 2 except 1 in itself. So I stand to be corrected there. All other even numbers can be factored down more. They're not prime numbers, but 2 is. So this said, I asked what a prime factor is. Prime factors are the prime numbers that will go evenly into 12. So what I teach students to do, and you may remember this from being younger, is the factor tree. You find 2 numbers that go into the 12. It doesn't matter which ones, 6 and 2. 2 is a prime number, so we're done. We can circle that. 6 can be divided into 3 and 2. 3 and 2 are both prime numbers. So the prime factors of 12 are the numbers that I have there in red. And so what we do is we write that as 2 times 2 times 3. Those are the prime factors of 12. If we multiply all the prime numbers up, we will get 12. And you can do that with any number. The larger numbers, it gets to be a little bit tricky. Let's look at something like 525. And I want to break that up into the product of primes. So I find 2 numbers multiplied together to give me 525. It doesn't matter which ones they are, as long as when you multiply them together, you get 525. So 5 is a prime number, so I'm going to circle it. That tells me I'm done with it. 105. Let's see, what goes into that? Well, it ends in 5, so I know a 5 goes into it. And I also know a 21 goes into it. Are any of those prime? Yep, the 5 is prime. The 21 is not because it can be broken down into 7 and 3. Are those 2 prime? Yes, they are. So the prime factors of 525 are 3 times 5. And there's another 5 I have. I have 2 5s and a 7. Which means if I multiply those 4 numbers together, I'm going to get my 525 back. So what I did is I broke those down into a product. A product is an answer to a multiplication problem, so they're multiplied, of primes. And a lot of people will rewrite this as, since I have 2 5s here, they'll write 5 squared times 7. So they'll put the number of common number and they'll use that as their exponent there. Means the same thing. So that's it for lesson 1.1.